Leo, how do you think if you start, or
Yeah.
you want to wait a little bit more?
Oh, I think we should go. So, hello everyone. Thank you very much to be with us today. We for us it's a pleasure, and it's great to uh, announce the new version of Proteus 8.12. And so let me introduce myself. My name is Leandro Silva. I work for Edasim. I am the sales executive for Edasim here in US and Canada. Today we have Mr. Israel Rodriguez. He's our engineer and he will be doing the presentation for us today. So to start, I'd like to just thank you again to be with us and talking about a little bit about Edasim. Edasim is around the not around the world, but we are covering we are covering all Americas,
Right.
South America, Central America, uh, Brazil, Mexico, Argentina, Chile, Peru, Colombia, Ecuador. We and now USA is the newest location that we are covering. So, um, talking about Edison, we have a few other products that, if you are interested, you can go to our webpage and check our products. We do work with electronics, simulation, radar training system, and robotics for educational. And talking about today, the version 8.12, Proteus version 8.12, this Proteus is manufactured by Lab Center, and Lab Center is located in UK, England, and they are with this product about 30 years, and a lot of universities around the world, especially Brazil, South America, Asia, Europe. They are produce a very no software in these countries, and we are working hard to make Proteus know very know in here in US. We have few customers that it's working in Proteus right now. We have Jason from Ryerson University. He's Ryerson University is in Canada, and he's here with us today. Thank you very much, Jason. Also, Purdue University is using Proteus. So thank you again. Talking about the schedule for today. We have a 90-minute presentation, and please feel free to turn your mic on and make a question. Israel, he's going to be able to respond. And thank you again. Israel, go ahead.
Okay, thank you guys. Thank you, Leo. Thank you everyone to be with us today. My name is Israel Rodriguez. I'm Brazilian, so I try to do my best to the English. So, but I think it's enough to talk about the new features of Proteus today. So our schedule, well, anytime if you wish to open your mic, interrupt me, no problem. You can ask me anytime, okay? About the questions that if you have. So about the technical content, you are talking about a very nice integration. It's not actually new feature, but it's a new approach using Proteus for ARM architecture to use STM32Cube. Jason there you know very well, he's working a lot on this from Canada, from Raisin University. So you use this approach to talk about you, if you, to talk about in the seminar or webinar, to get more deep information when you use Proteus on ARM architecture. So also it's very fast. I'll just comment with you that inside Proteus today is possible to also integrate with SnapEda. SnapEda is a component provider that inside the schematic on Proteus, you can just download the components from SnapEda today in the new version. And before, it was also integrated with some MCUs. So just talk about this very fast, this new feature to integrate SnapEda. This is nice. It's a multi-board design project for product development. So today, if you have a main board, for example, you can have just one schematic with several boards. So one product, if you have a computer, in computer you have the main board, you have the memory board, the graphic board. So this is a product. So Proteus now allows you to do a schematic with different kinds of different boards. So I will talk a little bit about this new feature on Proteus. Using this feature, for me, in my opinion, it's the best new of this new version. It's a multi-simulation design for not only Arduino, Raspberry, but also for MCUs. I mean that it's possible, for example, to do a project with Arduino boards and simulate Arduino sensors, actuators, and displays, coding flowchart, C coding or Python, and simulate together to 2 or 3 Raspberry Pis, or for example, a ARM architecture or a PIC microchip. So you can simulate a system all together in a single project. You'll make a very nice project in this. It's very nice. This is cool, really. So finally, related to a Proteus Cloud version, Proteus Cloud allows the student, the professionals, or the teachers work in their homes to validate the license of the cloud server. So we have a new features about security, about reports, about logs, about usage. So we have a new nice features for administration on Proteus Cloud license. So just to remember, I know everyone know Proteus. Proteus, I go fast just to talk, just to make an overview very fast here. It's a great solution for teaching remotely because never will the real life lab will be substituted by a virtual. But it's a very nice solution because you have a oscilloscope, virtual analyzer, and all instrumentation that allows you to simulate analog digital components, microcontroller components, embedded system, and so on. So Proteus allows you to do 5 kinds of simulation. The first one, it's very common. It's using SPICE language for diodes, transistors, operation amplifiers, and so on. So it's a feature common today. Several softwares on the market allows you to do this, but this one is new. Not new, it's unique on Proteus. What you call co-simulation for microcontrollers. So for example, you can design your product or your embedded system using any kind of this microcontroller like ARM architecture, Texas Instruments, Piccolo, AVR, ATmel, ATmega, microchip microcontrollers, and so on. And you can include display actuators and so on, and also coding C language or assembly language and simulate the system together. That's a big deal to Proteus. It's not necessary any harder to validate a completely embedded system. I will tell a little bit more on this. Also, it's possible to simulate PLDs, CPLDs, and SPLDs. You can code in v8.12 or Verilog, and also compiling it, you get a GDEC file, and you can load it on the Proteus and simulate together to analog digital components. So very soon, we are developing a way to simulate also FPGAs. Lab Center is working on this feature. New feature would be nice. So it's another nice feature in the Proteus because you can simulate this kind of components together to analog digital components and so on. Also, as you know, Proteus allows you also to simulate and program coding Arduino and Raspberry Pi boards. I mean that inside Proteus, we have different kind of Arduino Raspberry Pi boards together to sensors, actuators, and displays from different suppliers like Seed from Europe, Adafruit from US, SparkFun, NP Moroni from UK. So it's a sensor, ultrasonic ranger, sound sensors, humidity, temperature sensor, that all these sensors are modeled inside Proteus, and you can validate your prototyping, including Internet of Things project. For example, you can use or develop a human interface machine to be monitoring a weather station, for example, or control a robotic turtle, and you can on your cell phone in your or your tablet device. So Proteus allows you in Visual Designer and IoT Builder to do this kind of projects using Arduino Raspberry Pi boards. Okay. Also, finally, Proteus also allows you to do schematic, of course. And after you done the schematic, after your schematic is simulated, it's validated, you can move to the PCB environment. On PCB environment, you can place the part, route the tracks, insert advanced rollers like time delay, at length math, and you can do single board, double side board, or multi-layers boards. You cannot today do just one schematic, have a different kind of boards for a product, and you can export these Gerber files to produce the board. You can integrate to Autodesk, Mechanical Desktops, Pro Engineer, and to see how the board will appears inside a case, for example, and you can integrate with an MDA technology. So it's a very nice solution from the scratch on the schematic. You can teach it since electricity, simulate electronics, advanced microcontrollers, Arduino boards, Raspberry Pi boards, and finally you can do the boards if you wish. You can develop your PCB design. So it's like an overview on Proteus, very fast, just to remember that Proteus allows you all these kind of projects from scratch up to you develop or produce your PCB design, your board. Well, let's go to the live demo. The first one, I will explain you how to integrate or how to simulate ARM architecture, a Cortex M4 in this case, using STM32Cube IDE, MX to generate coding, and use STM32Cube EDA to edit and compile the coding. So the idea, just before I go to the STM32Cube, just to remember the big advantage of Proteus. I told you before, it's a co-simulation for microcontrollers. Remember, I told you here. And just remember that the VSM, virtual system modeling, it's a big deal to Proteus, because if you compare the traditional cycle for developer embedded system to the Proteus, is very easy to understand why Proteus is a nice tool to use in this case. For example, here, if you see in the traditional one, you need to have the PCB design. You have to do the schematic and do the PCB design of the software, any software, and produce, and you can wait about 2 weeks to get the real board, assemble the board, do the prototype, and after that you can validate the system on this orange block here. In Proteus, you can just do the schematic, and as soon as you finish the schematic, you just do the coding and validate the system, the same orange block, before you go to the real board. So in this cycle, it's easy because it's all virtually. You can validate the system. The probability of you need to do 2 or 3 physical prototype, is less on comparing this one. So it's a big advantage of Proteus. So Proteus is the main screen of Proteus. If you see here and do a new project, just to tell you this what I'm talk about. Just go create a new project. You not create a PCB, just to show you this VSM feature. If you see here, you can create a firmware project. If you see here, let's say that you're going to create a microchip PIC 18. So you can select any microchip PIC 18 that you want. And here you have to select the compiler. The compiler, if you see here, that's what I want to show you. The compiler, you can set up your own compiler. If you see here, you know all several compilers here for microchip PIC, for Python, for ARM, for 8051, and so on. So you can set up, download, and configure your own compiler if you wish. Because you selected the compiler, go ahead and finish. When you finish, it is your first screen of your embedded system. So if you see here, I have a microchip PIC 18. So now you have to start doing your schematic, for example, resistor, connectors, and electromechanical components, step motors, and so on, memories IC, and so on. So if you don't have, for example, a component, let's say PIC32, let's see if it's working. Yeah, it's working. If you see here, I'm connected to SEM-axis, and here below Snappieda. So let's say if you don't have a PIC32, and you can look through Snappieda to download this component. Just click Snappieda. If you see here, it's looking through the internet direct inside Proteus. So you can starting to develop your coding. Just if you click OK, you can import this component. It's not common, just importing the component that I just downloading just in this second from the Snappieda library. So in this way, you start to develop your schematic. Here in source code, you have the code to start to developing. So you start to code in here the information, and you can just build the project, and you'll be able to simulate the embedded system. So in this way, this is a very big advantage. So now, as you see, we can integrate of different kind of compilers like these ones. Kyle microcompilers is for ARM architecture, microchip PIC, and so on. So if you know very well this third-party tool integration for Proteus for compiling a C or assembly coding, but also we can integrate for another system. For example, in my last webinar, I did an integration with Arduino board using a ESP8266 to send information to the internet to MySQL database for a temperature sensor. It's very nice. If you wish, Leandro or me can send you a link where you can see this integration. So today, I will show you how to integrate STM32Cube, as I told you before. And then our next seminar, we are going to integrate with MATLAB Simulink, just to simulate a validator system. We will do this in the next webinar. So in this today, just remembering how Proteus can integrate with different compilers and different systems. And today, the very fast way, I'll show you how to integrate STM32Cube. Okay, so how it works? Proteus simulate coding, compiled and generating coding using STM32Cube IDE MX. First, I'm going to show from scratch. I'll create a schematic from scratch using a Cortex M4. First of all, the schematic what you want to simulate. After that, I'm going to create a project and generate a C code using a Cube MX. Okay, just to set up my Cortex M4, where is my input, where is my outputs, and generate the coding and the libraries and the age files for it, and edit this code using Cube IDE. Sorry, this Cube IDE you can use instead. For example, a Kyle, a MDK ARM. I will show you some integration also, but in this case, you are going to use this one. And after that, you have to compile the code and obtain the X file, AGEX file, to simulate inside Proteus. That's one way to integrate this simulation. I'll show you another one after we finish this one. After this, we have an X file, just load the compiled code inside Proteus and just simulate Proteus VSM. So let's do this project, okay? If you have any question, please go ahead. I will show you here. I start Proteus again from scratch. It's a main screen of Proteus. I just click here on this icon. I don't need to create a project and so on. Yeah, a fast way to create a schematic, just open the main screen of Proteus and click this icon. This icon just open a blank project just to start to working. So let's insert a component STM32F401 VC. This is a component I'm going to use. It's a Cortex M4 up to 84 megahertz at 32 bits. It's a very powerful component, but a very powerful processor. If you see here, we have two kinds of PCB footprints. For example, we have a QFP and a BGA. I'm going to use a QFP, okay? I show you how and where I'm going to use this. Just select this one and insert on my schematic. So here, let's say I do a very easy project. The idea here is not complicated, just to show you a fast way to integrate the cube with Proteus. So let's say just click a push button and turn on a LED. So for this, of course, I need a button. So let's search a button the library. I need a resistor, this one for the LED, yellow LED, this one. And let's put another resistor for pull up and pull down resistor, 4K7 resistor, metal film, this one. Okay, so now I have just a very fast way to how to, if you don't know Proteus, just it's a nice, because just an introduction how to start a project. This way is a way to start any project. Okay, so button, let's say that PD10 will be my input. I gonna to configure my PD10 as a input. So I'm gonna to connect my input push button, and let's connect here my resistor, this one. You use also a yellow LED for, let's say that a PD15 will be our output. I'll configure this in Cube, okay? So this is my output, PD15, and my PD10 will be my input. So this is my very easy, very fast schematic. I just insert a ground here, and power to pop up here to my pop-up resistor information. Here we go. That's all. Just connect this to VCC, and that's it. So just to show you how easy to schematic, how to capture a schematic. It's very easy. So in PD10, it will be my input. In PD15, my output, okay? So let's now start with our MX Cube MX. I start the MX. This is free. It's from ST. It's the STM32Cube MX Cube, actually. It's a tool of free of charge tools that allows you to do any kind of project using ARM architecture. It's very nice. It's impressive because it's a powerful tool to get coding, very fast prototyping. So first, I use start my project from MCU. So I click this button. Computer, come on, here you go. I choose the same one, STM32F, remember, 401 VC. If you see here, we have two PCB footprints, remember, but BGA and QFP. That's why I selected there QFP. So I use select QFP and start my project. When I start my project, I get my workspace here. Here we go. So now I just starting to configure my component. I just, if you see here, I have all the ports, PA, PD, PC, PD. So it's possible to configure my components, GPIO, clocks, and so on. Here, I'm not gonna deep in on this, but just to provide you an overview. Remember, PD10 will be my input. If you see here, PD10. So I just select this pin and select input. So I just configure my GPIO as input for PD10, pin 10 of D port, and PD15 is here, PD15 as my output. That's all. That's it for my component. Let's come back here just to show you another interesting thing. If I go double click on my component, if you see here, I'm using external crystal frequency 80 megahertz. So I just configure my clock configuration to be also in 80 megahertz, just to match to this simulation Proteus. Okay. On project manager, I just provide a name, webinar. Let's say US and Canada, just put webinar US, that's it. And here we have to select which IDE I'm gonna to use. You can select anyone. So in this case, if you see here, we have a MDK ARM, or you have a STM32Cube IDE. So let's choose this one. I can choose anyone to compile and also to generate the X file. So let's use this IDE. After that, I can show you another example. So that's all on this configuration. You can generate now the code finally. So when I generate the code for the another cube, you get the generated code done, and you can open and start to coding. So I just open the project, and the cube IDE is open. Just launch my workspace on this folder. Remember, the name of this project is Webinar US. Come on. Oh, it's slow. That's okay. If you see here, wait a little bit more. Webinar must appear here. Webinar US. Here we go. Okay. So now I have all my code here. My includes the drivers, all the information I need to compile and to start to build my project. So if you see here, I have src and the main .c able here to double click and start to coding. Let's do this coding just to finish our project. If you're looking here for infinity loop there, while one, use the code here. So let's start to coding using how commands. So if, let's say how GPIO control space, oops, sorry, how GPIO control space, read pin. It means that they gonna to read the pin on the port D, but which pin? Remember pin 10. My input was pin 10. So I'm gonna to read PD 10. So PD10, if this means that if I click this one, check the button, let's say, check the button. If the button is pressed, let's enter, do what? Let's haul again. It's very easy, right? You must know how GPIO control control space. Let's do right pin. Right pin, which one? Port D. Which pin? 15, remember? PD15. This must be uppercase. And pin state, just one. I mean, that's just turn on the LED, right? Hall, GPIO again. And oops, sorry, GPIO, no, Hall delay. Well, let's put a delay of 2 seconds. And finally, just is faster, Control C, Control V here. It's just turning off my LED. That's all for my coding, right? It's easy. I can code anything. I can develop with a very complex project here, just to let you know how the step-by-step to work on this inside Proteus. So I'm going to save this project, and now it's very, very important. You have to select your Webinar US, right-click, and configure, because you have to configure, sorry, properties. I go to properties, have to enable the X file to generate X file, because for default is not generating X file. So again, right click on our project, properties, go here in beauty, settings, tool settings, oops, tool settings, and yes, MCU post building outputs, and select this option to generate X file, okay? So following these steps to get the Xcode. So as soon as you get the Xcode, you can load the Xcode inside Proteus. That's the way, okay? So apply and close, and now you can compile. Let's compile the coding. As soon as finish, you can come back to Proteus and load this compiled code to simulate it. That's one way to simulate Proteus using STM32Cube. I'll show you another way also. That's better. But this is one way to work on this. Okay, almost there. Yep, you got it. no errors, no warnings. Great. So come back to schematic, double click on the Cortex M4. And here, if you see, you have a program file. So you click in program file and look at where I put this coding is here, Israel, this folder, Israel again. Remember webinar US, this one, and debug, and here you have the Xcode. So I'm gonna open this one and okay, and now you'll be able to simulate. So if I click here to simulate, the circuit is energized, so on. So if you click it, press button, after 2 seconds, they turn off the LED. So it's very easy, of course, it's very easy project, but just to let you know the step-by-step how to simulate a very complex circuit. If you wish, if you want to use another IDE, for example, you can just select, for example, MDK ARM, and go generate code. They're going to generate the code for another IDE. Let me explain to you another two IDEs. The first one was IDE for Cube. Another one is Kyle, ARM Kale, or Kale Microvision 5. It's open the Microvision. So it's open the Microvision here. So you can come back here to main project and you can start to code in here the same way that I do STM32Cube. It's another way to compile. You can go here in project, compile, all target, and you have you get the X file again, loading Proteus again. You can simulate using MDK ARM, Microvision. That's another way. And another way is, for me, is better, the best one. I'm gonna choose stop the simulation and forget this project. Let me open an example here of using. It's a nice, because just to let you know, when you open the main screen of Proteus, you have this open sample project, open sample button that allows you to open different sample circuits divided by category. If I want to see how works, for example, an Internet of Things project using Arduino, for example. So you Internet of Things, and you select here any project, Raspberry, Arduino, open and simulate. The same way if I want to see sample circuits using Cortex M3. So you select here, just open and try it. Let you open this one, for example. If you see here, also is using Cube MX, but take a look on difference on this. It's the better way for me choosing Proteus together to this STM32. If you see here, I'm not to use the X file inside the component. It's a Cortex M3 now, but the project it's a toggle this LED. But now I'm not using X file. I'm using if you see here, I'm using a ELF file. It means that it's possible to do debug inside Proteus because I'm using the Proteus IDE. If you see here, I have a source code, I have the main code, I have all the libraries and the includes file needed or generated on the on the STM32 Cube MX. So I just loaded this file here inside Proteus. So you'll be able to, inside Proteus, start to coding. If you see here, the same how commands that we use there, you can use it here inside Proteus, and you can simulate it. And this is nice because it allows you to do this kind of debug. If you click step-by-step project, you open the code in here, you open the variables, the registers inside Proteus, you open any kind of information of ports and I2C information and so on. So in this way, you can just step-by-step click several times and simulate step-by-step the project inside Proteus. You can just double click in any line of code. Let's say here, yeah, you have here breakpoints. So if you stop and start again, this stop in this breakpoint. You have all this information here inside Proteus. It's nice because you can use oscilloscope, logic analyzer, and all this kind of analysis, virtual terminal, pattern generation, voltmeters, logic analyzer, so on. You can use also analog and digital mixed frequency analysis. So you can use all this feature with for analog digital components together to this kind of debug inside Proteus. That's cool, really cool. So this is another way to work with STM32Cube. It's just the cube just generate the coding for ARM architecture project. So you can load all the generated code inside there here in Proteus and can start to coding and compile using any compiler. In this case, I'm using a GCC compiler. Okay, so if I just to show you, just change something. If I click here, they start compile again. If you see here below, I don't know if you can see GCC. It's a compiler that I'm using for this project. I'm really compiling inside Proteus. Use this core for this compiler. Okay, that's it. Compile again. Remember the breakpoint. You there. So that's all. Let's go ahead on this on the presentation because I have a lot of things to show you. If you want to go deeper on this, you can just open. You have different kinds of ARM architecture sample circuits here. If you want to work on real-time operating system, you have two examples here using Cortex M3. It's very nice. You can also select here different ARM7 simulating a micro Linux. You have M0 projects, M3, M4 using ARM architecture if you want to just open and try and take a look. After the presentation, if you want to evaluate Proteus, Leandro can send you an evaluation copy for a time that you can open and try Proteus if you wish. Okay, so let's go ahead. Let's say a little bit, so fast about multi-board design project for product development. This means just to let you know here, is provide multi-board design in Proteus provide a formal way to design products that consist of a single schematic but multiples rigid PCB boards. So if you see here, we have two schematic, main schematic, GSM and Echo. Echo is a DSP sound processor board for a company called, I forget this one, but here's, they use a Cortex M0 and a DSP processor to sound input and processing. And this is a GSM, just with a GSM model here to send information through or get information from GPS. And if you see, we have one schematic with two boards. So let's do an example very fast, just to explain to you how do this kind of project. Let's do a new project. Let's say PCB multi. This folder next. Gonna to create a schematic using landscape A4. Let's create a PCB design. If you see here, we can create a PCB design from a template. For example, if you are gonna to design a hatch or a shield for Arduino board, you can just select this one and they start a project with Arduino connectors, Arduino size, Arduino input power, and you just load your electronics inside this template. So you can load all these kind of templates if you wish. In this case, let's go default, do a blank PCB design. Next, and now this is stack up. This stack up is allows you to validate if your project is a double side board, it's a multi-layer board, and so on. In this case, I have a core with a FR4 here. I have a top copper, bottom copper. It's a double side board, top resistor, outside and bottom resistor. Resist. So let's say that they're going to stack up a wizard, and let's say that they're going to create a main a computer. So you have to have the main board. So the main board will be a complex board with 8 layers. So let's go. Okay. So this 8 layers set up here. If you see here's the core. Let's say that above the core, we're gonna choose besides signal, we have to choose plane. And this plane, you're gonna be VCC, power plane. In the same way, below the core, sorry, here you're gonna choose select plane again and do a GND. And two BGA components, if you're using ARM architecture, is very good to put a plane beside below of the top copper. So let's change also to a plane here of 3V3 volts. That's my main, that's the way just to show you how fast, how to set up a multi-layer board using, you can set up the different cores, the different thickness and so on, the electric constant and so on. So let's go next. Now I'm going to set up my vias. So my vias, right? Vias is this one. This is a true hole via. This is a blind via. This is a buried via. It's another blind via from bottom to top. These are three kind of vias that I'm going to use for this project. It's a very complex project. Let's go next. I don't want in this case use a firmware. If I want to configure, for example, a Cortex M4 for this board, you can use a PIC, you can use a Piccolo, DSP, and so on. So in this case, or Arduino boards, Arduino Uno, Mega, etc. In this case, it's not Arduino because it's a main board. And here a Raspberry Pi, but not. I'm gonna not choose to use a firmware for this project, just a PCB design. Go next and finish. As soon as I get the finish, I just set up a main board with eight layers. If you see here, have the rollers for the 8 layers, net class, differential pair, rollers, the full information for thermal relief, and so on. Here I have a possibility to include, for example, LED length delay to high-speed board design. You can use also, you can see again the stack cap if you want. So this way, it's not new up to now. You have a one schematic with one PCB design. But now, if this is new, file, new board. If I want to, in the same schematic, add different kind of boards, do this, file, new board. When you click new board, you come back again to the PCB wizard. So you can go next. Again, let's say that this board, you're going to be a memory board. So let's choose here for 4 layers for memory board. That's all. Let's go next. Here I'm gonna to create vias, but in this case I'm gonna to add a new one for by myself. From it's a via from top to inner one. That's all. Okay, you see here. This is a true hole via. This is a buried via. This is one that I create. Is a micro via. Could be a micro via, or could be a blind via. Just to show you the another way to create by yourself the vias. So finish. Now I have here 2 boards. One board, board 1 is a main board, board 2 is a memory. Let's say one more file, new board. Let's say that they're going to create a power board. A power board will be double side board. That's all. Next, through hole via and finish. So now I have 3 boards here. In the same schematic, we have board 1, board 2, board 3. So if you wish, you can go here on the Design Explorer and see the 3 boards. You can right click, edit name. So main board. This is the second one. Remember, it's a memory board. And the third is power. So in this way, just to show you how Proteus works on this kind of projects. If you see here the schematic, I have a main board, memory, power. Main board, let's say that I'm going to create a new sheet. So this one, designing, where is it? New sheet. So now if you see here, I have 2 ones. I have 2 pages. If I want to page 1, for example, .sch, here page 2. So you can configure it as you wish. Page 2.sch. So if you see here, you have a very nice way to administrate your 3 boards. And here on the layout side, we have the same way, main board, memory, power. So let's show you an example. Just a second. Okay. So let's open here a sample board. Open sample, open project. Have one up board for you guys to show you this one. Yeah, this board is that one, this GSM board and Echo board. So if you see here, I have Echo board and GSM board. Echo board has a Cortex M0. Oops, here with the power supply and all the peripherals here, the jack input. And if you right click here, you can have sheet 1 and page 2. If you see the page 2 has the jack connectors and so on. And the same way for GSM. GSM, I have here the GSM model. And we have power supply, power regulator, and right click, you have here page 2 with connectors. So you can move through this schematic using also the Design Explorer. If you see here the GPN, GPS in the Echo board. If you see all the components is here, and the last one was there's no components. So it's not just components. If you right click here, you can see the netlist view. So if you see here the netlist view, you see where is the connections, which are the connections, where goes the connections. You can highlight on the schematic, highlight on the PCB, and navigate all the projects using Design Explorer. If you see here also, let's say right click, part list view, uh, the uh, the Cortex M0 must be any place. Well, let's come back to schematic, come back to sheet one. Here we go. And the same way on layout side, we have now the GSM board. These are the GSM model, and you have here the Echo board also. Is the Echo board. So you have now in one schematic, you have two boards that you can generate together, the documentation, or you can generate separately. So if you see here, also you can see the boards in 3D dimension. It's a GSM board. This is a Echo board, sorry. This is a Cortex M0, connectors and so on. You can validate the board and see the board in 3 dimension. You can export this to MDA or SolidWorks mechanical desktop or engineer software. You can see the boundary. If you have some interference like this crystal, you can put out the components, just see the boards. And this is the Echo board, right? If you see here, we have also, if I click here, Echo GSM, I just open the GSM board, and you can see here the GSM board in 3D dimension, also the tracks and so on. So in this way, you can validate the system, your product. You can generate the reports and the output files. If you come back to PCB here, environment, you can, for example, generate the bill of materials. If you see here, bill of materials, and the bill of materials is really online in bill of materials. If you see here, GSM bill of materials, because it's GSM here. If I move to Echo, if you see here, Echo, let's say that I'm gonna to, if you see here below, take a look on this, is Echo right? Sorry, here, U6. U6 is my Cortex M0 schematic, Echo, page one, this one. If you see here is a U6. Just to show you how impressive is this bill of material. If I change here, U6, let's say U66, just to show you some difference. Bill of materials, again, Echo. And if you see here, automatically this is updated. Not just the reference, but stock code and values and so on, U66. And the same way happens on the schematic side. If you see here in the schematic side, let's zoom. Let me delete this one. If you see here, U66. If I select this component, right click, edit properties. Let's say now is a U100. So I just change this. On the schematic side, you have this change, and the bill of materials also. Just to show you how dynamic is the bill of materials, is very nice. Is some kind, not just bill of materials, but the integration between schematic and layout board. It's not necessary to loading and exporting any file. It's just one environment for real. Also, if you see, I like to show you project notes. On project notes, it's like a documentation that allows you to generate a documentation for your project. For example, if a specification document, like a PCB manufacturing document, information for manufacturing. If you see here, you have information, board stack up for manufacturing, a kind of vias. Of course, these are Echo. So if I click GSM, it's 4 layers. Here you go, 4 layers. And you have all this information. If you see, it's nice because you have all information to manufacturing. If you want to generate more information, you go here and select, for example, drill table. So if I click drill table, here we go. Here's the drill table for GSM. If I go here, length match for, there's no rulers for length matching because that's why there's nothing here. But if you come back here, gonna to variant comparison, variant is possible to use also Proteus, two kind, 3, 4, 5 variants you can use, design handlers, fiducial, your table, layout, stack up, like I showed you before. So in this way, you have an schematic, just one schematic with two PCB boards, documentation, 3D visualization. You can export this for mechanical CAD, like a step file or 3ds. Bill of materials, project notes, you have this in just one environment. That's the power of Proteus. Now you can work for a product development. I think in product develop is this. I don't forget. I just forget to show you. It's possible, for example, to go in output and generate Gerber files. If you see here, pick and place for pick and place machines, or if you wish, you Gerber file and Excel files to produce the printed circuit boards. And you select the layers that you want to generate and go OK. You can generate a zip file if you wish. If you go OK, it must open on my computer. Let's see. Here we go. Here we go. This one. It's a Gerber file generated by Proteus. This Gerber file can import and send it for any manufacturer in the world. On the world, anyone can produce or not only manufacturer, but prototype machine, mechanical, laser prototype machine. You can export and produce the board for real. So that's the completely flow, just to show you a fast way how to produce a multi-board design. Okay. Let's go forward. The last example, it's the nice one. It's a multi-simulation design for Arduino Raspberry MCUs. It means that in Proteus, you can code, simulate, debug, and deploy two or more development boards and any supported microcontrollers in one single project. I mean, if you see here my sample, I have an Arduino board here, another and a Raspberry Pi board here in the same project, and below you have a ARM7 microcontroller. So you can coding the Arduino in C language, you can code the Raspberry Pi in Python, and you can code here in C language also. Or actually, you can code in Arduino in blocks, for example, flowchart. Let's say to do three kind of coding in the same project in blocks, flowcharting, here in Python, and here in C, like you can see here. So in the same project, you can simulate all together, integrate then using RS32 serial communication. You can use RJ45 for Ethernet network. You can use to, for example, in my example, we're going to use a MQTT protocol to publish information from Arduino Yan on the cloud broker. And you can get this information using a Raspberry, for example. And so you can do a very complex project in just one single project. So it's very nice. Yeah, for me, it's the big deal in this version. So let's say now in Latin America, every place you go, every supermarket or mall or commercial center, you have to take your temperature, right? So this device is very known for everyone. In US, I think it's the same. I'm not sure, but in any place and any time someone get this information on get your temperature inside entering in mall center, for example. So let's say now let's do a project that I'm Brazilian, but I'm living in Bogota now in Colombia. Because I take care about the business of our company outside Brazil for Spanish speakers. That's why I'm in Bogota now. And let's say that in Leandro, my friend, my colleague, is in Miami, in US, in Florida. So let's say that there in Florida, they are going to take this temperature. And I can see the temperature that Leandro is taking on their home in my cell phone or in my tablet here in Bogota. So remotely, I'm going to do a project to validate or to get the information through the internet remotely of the temperature. So that's my project. For this project, I'm going to use here Arduino Yan. Arduino Yan is a nice board because it has a modem integrated. so I can connect directly to the internet. So I'm going to simulate on Proteus a temperature sensor and also a ultrasonic ranger to measure the distance. Let's say that the distance to send the information when you click, you have to be less or equal 15 centimeters, let's say centimeters, sorry. So that's the project. So as soon Leandro there can get this information, Leandro, the Arduino board must to publish it on the cloud using MQTT protocol. If you remember, MQTT protocol is a protocol developed by two engineers from IBM on 1999 to be monitoring the pipeline in the desert remotely using satellites. So they developed this protocol because the cost of this and this at this time was very high. So they developed a uh, very low flow protocol because as much you pass information through the satellite, more expensive is the service. So they develop a very easy protocol to be monitoring this pipeline in the desert, pressure, temperature of the oil pipeline. So as they decrease a lot the cost of this service. So this protocol after the 2000 turned like public, and today is very useful for Internet of Things projects, for house automation, and so because the idea here is to publish a lots of sensors and subscribe just the sensors that is up to me. So you can publish 10 sensors like temperature, ultrasonic ranger, and so on, humidity, and so on, and just publish and just subscribe just information that is up to me, like temperature. So I'm going to use this broker, this protocol to do this kind of this project today. Okay. So the idea here is to get the information, send the information through the internet, and you can see over there where you are. I will show you a way to show you how you can get the information that I'm simulating here in Bogota through this broker on cloud. And after that, I'm going to do a project to subscribe using Raspberry Pi and develop a control panel to do a graph, a chart to get the information on the temperature that you're going to read. Okay, it's a very nice project. It's easy. But I can do this project in 30 minutes, but I do less because this side on the publish is done. I just do this side, okay? Just should not do, I spend a lot more time of you. So let me show here the Proteus software and let's start the project, okay? So I'm going to exit this one. No, it's not saved. I'm going to open the project. That I prepare for you, this one. I don't know what time is it. Let me see.
2:03.
Have you 30 minutes more, right?
Yes.
Okay, it's enough. So this is the first part of the project. Okay, yesterday and before yesterday, I did the same seminar in Portuguese and Spanish, and I did this project completely, but it spent a lot of time. So I just I split in two parts. The publish, is done, but I gonna do with you from scratch this one. Okay, is the idea is to show the new feature. So I gonna to start from the new feature. Okay, now let's see here. If you see here, I have also the real board here in my hands. I don't know if you can see there. I have here Arduino board. I can, if you have time, I can show you for real, it's working. It's Arduino Yan. Connect here a shield. This shield is used by this company called Seed. This company Seed provides this kind of sensor. It's like these boards. It's called Grove. This Grove is ultrasonic ranger that I show you. These are just a push button. Here, LCD display. is already done, is working, is connected in my power cable. And this board, as soon as I connect it, it's connect to my my router here in my home. So this board is connected on the internet and can send information to this broker that I show you. This project is the same one here in Proteus. If you see the same ultrasonic ranger, the same temperature sensor that I show you, I don't show the temperature sensor, sorry, is a thermistor based temperature sensor, this one here. Is this temperature sensor, the LCD display. And here, if you see the push button, the idea here is the following, is to, if the distance is less than 15 centimeters, I can click the button, push button, and they send this information of temperature to the cloud. So in this way, I show you the same example using Raspberry Pi, how to create this sensor, this schematic I show you, but I show also how to create the coding. The coding for this, I did using blocks to be faster. So the code is divided by three ways here, or four. The first of all, I have to read in centimeters, read in Celsius. So it's these blocks just read sensors, distance and temperature. Okay, that sensor that I show you. And insert on this variable, CM, variable integer, and variable here, and temperature, Celsius, in temp C, temperature floating variable. Okay, this is just reading the sensor information. After that, just printing on LCD display. To print an LCD display is very easy, because just set the cursor for, remember that this LCD display has two rows and 15 columns. So I just print in this way here on the column 0 and row 0, just a distance, and one temperature. I'll show you in 1 second. And the third part of circuit, you have here the button and distance sensor condition. I mean, if I click that button and the centimeters is minor or equal to 15 centimeters, do the following: connect to where? Connect here using MQTT protocol. If you see here, when I use this block, this connect block, I'm just connected to test.mosquito.org. This is a broker on the cloud. This broker is free. You can use it to send information, get information. It's a broker called Mosquito. You are gonna use this one to publish the information for real. And when post this block, just connect this block, and after you get connection, you just publish a topic in a message. So the topic will be the topic is follows here like a hierarchy. Like I am on the mall, I am in the one on the mall, and I publishing the distance sensor, and this is the mall port 1 distance. So temperature. In distance, I'm going to send the message CM. The message CM is the, if you see here, is the variable that I insert, sorry. I insert here CM variable, remember, and temp C variable. So this is the message that I'm going to send to the broker. So I'm going to publish two information. Remember, the protocol have to read the information and publish on the cloud. So now I'm publishing. Now, as soon as I finish the publish, I just disconnect, and that's all. If you see here, publishing on MQTT broker and using this this protocol. That's it. Okay, this decoding is gonna not spend more time here, and let's try it before I go forward. I'm going to simulate the project. I have the code already compiled to be faster. And if you see here, I have the schematic. The schematic is opening. Okay, let's try it. Let's try. I ask you for your help. If you wish, you can follow me now. Open your computer in a browser, and I'm gonna put this MQ test client link for you on the Zoom chat. If you see on the Zoom chat, I just put this information. If you wish, you can just click there and open just to get the information on the cloud that I'm gonna send and publish here. From Bogota, you can get this information wherever you are. Okay, just trying to connect is a little bit slow. If you see on the Zoom chat, just open the Zoom chat and I send the link in there. Why is not opening? There, here you go. So if you open, you must get this screen, okay, over there. Any place you can get the information that I'm sending from the Proteus simulation on the cloud, on this real cloud, real broker, sorry. And here, if you see, you have different kind of brokers, and you are using the Mosquito. So select here on the pop-down menu, test.mosquito.org. Just select it and connect. If you connect it, you get the green information here. That means that you are connected. And now you have, remember, the protocol is you have to publish and you have to subscribe. So I have here subscriptions. I have here the publish. If I want to publish any information using a topic on the cloud, you can use this. And this way, in this time, you're going to subscribe. Remember, subscribe which topic you're going to subscribe. Mall, remember, you are on the mall, you are in the P1, part 1, and you have to get this distance. If you with no codes, okay, just this one, with no code, just like me, mall P1 dist, and click on this button called subscribe. When I subscribe, I got the information there, and then let's subscribe again. Another topic, mall P1 and temperature. Okay, same way, mall P1 temp. If you get this, subscribe, and you have now connect to the test.mosquito.org on the MQTT protocol on this broker for real. And I'm subscribed on 2 topics, mol P1 temp, mol P1 dist. It means that if I come back to Proteus simulation, if you see here, the simulation started. If I click public, if I click the button to measure the temperature I'm simulating here about 35 degrees Celsius. Here you go. I'm simulating this temperature. If I click here, I must get nothing there on message because I'm more than 15. If I come back here to decrease the distance, I'm simulating the distance on ultrasonic ranger. If you see here, 16 also in distance. So I'm going back to distance. I'm simulating 15 centimeters. Okay, now if I click, remember the coding is equal or less than 15 centimeters, you're going to publish if I click the button. So if I click the button there on my MQTT protocol, you must receive, if you do the follow me, you get over there in US or where you are, you can get the information that Proteus is simulating in publishing on the real broker. It's amazing, right? So 15.
Yeah, I got it.
Got it? Great. Thank you, Leo. So you have here 35.94 degrees Celsius. If I change the temperature here to below or to go there, if you see it's not working properly. If you see here 29 and means here 32. This is the correct temperature I'm simulating, okay? I have to talk up to Lab Center to correct this one. So if you see 29, but actually not 29, it's 32. Let's publish 32 and let's publish 13, okay? Publish. If you come back there, you get 32 and get 13 over there in your computer. In this way, now I get my project, the first part of the project done. If you remember here, my project was sending temperature if I am on the distance condition through Arduino Yan to my broker, Mosquito. Now I have to do the second part of the project. Now I'm going to do from scratch with you, okay, on the same project, of course. Let me show you here. So it's Arduino Yan, right? It's connected to the server. Everything is working properly. So I'm going to stop the project now. And now is the new, for the new version, for the 8012 version. If you see here, we have Arduino Yan, correct? And now I'm going to go project and create project. The same way that before I create a new board, this multi-board design allows you to do also multi-layer simulation. So if I select project and create project, it means that I'm going to select which project I want, which project I feel if you see firmware, I can select, for example, remember Cortex M4. I can select here to compile with KO, compile with CCS. I can use the compile decode there, STM32Cube, and load here inside Proteus and simulate together to Arduino Yan, for example. Or if you wish, I want to use a ARM7, a PIC microchip, any components, and also I can use another Arduino board. You can use Arduino Leonardo, Mega, Nano, Uno, Yan, and Arduino Cloud together to this Arduino. Or if you wish, you can use Raspberry Pi 3, 4, and 0. In this case, I'm going to choose Raspberry Pi 3 with Grove P hat. Grove P hat is that hat that I use to connect. This is the Grove P hat, this connection in blue. Okay, I have the Raspberry Pi board in my table here. I show you if you have time to see in the real, but I'm going to simulate first. Okay, so now if you see here, flow chart, it's possible also if I don't want to code in flowchart this Raspberry Pi, I can just select firmware, go here down and select Raspberry Pi. And if you select Raspberry Pi here and Raspberry Pi with hat and go OK, they are going to create a Python project. So use a Python environment. So you can start coding Python. I'm going to code in blocks, it's faster. And after that, we can convert the blocks in Python and also in C, just to show you how easy to do this. So now create flowchart project, Raspberry Pi 3, Groovy Head, that's perfect, go OK, and start a project from scratch here, just to show you how it works. So now I have the flowchart environment, and here, if you see, take a look, that's nice. I have Arduino, Raspberry Pi. If I wish, I go project, create project, select any project that I want, and go and simulate all together 3 or more projects here using different technologies. It's amazing. So now, if I come back to schematic view, if you remember board 1, board 2, remember, if I go here to Design Explorer, we can, for example, rename this name. This is the Arduino Yan, and this one is the Raspberry Pi. Just to show you this nice Raspberry Pi. If I come back to schematic, if you see here, I have Arduino Yan that you know, and Raspberry Pi board. This is the Raspberry Pi board, ready to start to coding and start to add peripherals. In this case, I'm going to create a control panel, a human interface machine to create a chart to validate the information that you reading on the device to read the temperature. That's the idea, okay? So now, let's see if you see here the Visual Designer tab, save, have here Arduino flowchart, research peripheral. The same way I have here the Raspberry Pi flowchart peripheral research. So let's start the processing here on Raspberry Pi, right click and select IoT, add IoT control. When I click add IoT control, it opens the controllers that is a library of controllers that I can use to develop my human interface machine to deploy to cell phone or tablet. So in this case, I'm going to use here a chart controls. Chart controls, you have different kind of charts. In this case, I can use a chart with a time domain, but I'm going to use a chart with a X value domain. I mean that, let's say that on the X, I'm going to get the person 1, person 3, 4, 5, 10 person, and the Y X, I'm going to get the temperature. So that's the chart that I need. So I'm going to add this one, If I add this one, they open here the control panel. I'm going to start to design, but I'm going to include also another things. I could use timers, clocks and timers, dials and sliders. In this case, I'm going to choose a thermometer. I add here. If you see here, I've had the chart, graph chart, and here a thermometer. I'm going to choose also a set segment display. Add to count how many people gonna enter in on the shopping mall, for example. And also, let's say that if we get someone with more than, sorry, in degrees, I don't know Fahrenheit, maybe Leandro can help me. In degrees, it's 37.5, you have fever, more than it. I don't know in Fahrenheit, maybe Leandro can help me. And let's say if
I believe 99, right?
99. Sorry, I'm working in Celsius, I'm sorry. And so let's say that if you have someone that are reading the temperature is more than 37.5, you have to turn on the red LED. So add this one, I just read one. And if I have more than 6 people, we have to turn on a green light. Okay, that's it. That's all for my control panel. Take a look. That's very easy. Now I have the control panel here, and I just drag and drop the controllers. So here's the graph. That's it. I think this is okay, this size. Here is the thermometer. Let's resize the thermometer for the control panel. Okay, I can put a background here. You can set up it as you wish. I'm gonna go fast to don't spend a lot of time. So this is a LCD display. Sorry, this is a this is a display, and now we have LED one. LED one is for temperature, and LED two is for people. And also, if you wish, you can insert, for example, a logo. Let's insert our Edacin logo. That's cool, right? That's it. That's my control panel. It's so easy, right? Can resize the components if you wish. You can do whatever you want. There. It's not too good. It's not on the center. But just maybe this one is too much. Oops. Yeah, here we go. So now let's configure this environment. So first, let's change the label for the ready label, ready light. Let's change the name. If you see here, I click on the label, and here below, open the information, the size, the geometry information, and so on, the color. So if you select here on the red one, I just change the label to alarm. So if we get more than this temperature, just turn on this light. And this one is capacity of people inside the establishment, inside the mall. I don't know. So now let's see the graph. The graph is here. Let's change the name. Let's change the X range. The X range will be from 1 person to 10 person. Okay, so let's set up the range from let's say 0 to 10. Okay, 0 to 10. It means that the first person or the first information that I get from the MQTT protocol, I just plot on this one. Another one, 2, 3, 4, and so on. More than 6, more or equal to 6, must turn on the red. And more than that temperature, turn on the red light. So if you see here below, I have the columns now. The columns, I just changed the name of columns to temperature. Degrees Celsius, okay? Just set up in my graph. And the value of this one, you're gonna start, sorry, in 35 degrees Celsius to 40, okay? From 35 to 40 degrees Celsius enough to validate if the person has or not fever. So if it more than 35.5, you have to set up alarm. Okay, that's it. That's my control panel. Easy, right? It's very nice because you can deploy it to the cell phone, and you can do a very complex human interface machine as you wish. So now I have to code it in blocks, the Raspberry Pi. So I save it, and if you see here to navigate through the Raspberry Pi, if you see here Raspberry Pi, we have here the main control for our control panel, and I here flowchart main files. So if you have main, double click, it's open the code environment. This code environment code is in flowchart, but you can, again, you can code in Python if you wish. Just I increase the size here because I need more smart space, okay, of this environment. That's enough. And let's start to coding. Now, the first thing that I need to do, remember here, is to connect my Raspberry Pi and subscribe to that topic. So the information is already on the cloud. Now I have to subscribe that topic. Okay, so first of all, I have to enable the MQTT protocol. If you see here on peripherals, I have MQTT protocol disabled. So I have to enable it. So now it's enabled. As soon as I enable, I can expand it. And I have all comments here to start to coding. So first of all, I have to connect. Remember, I'm going to connect my Raspberry Pi where? Double click on MQTT protocol. I'm going to connect on test.mosquito, .org. Let's see if this is okay, .mosquito.org. That's the same broker, correct? So I just put the connected block on setup just to make sure that all the time I'm connected to this broker, okay? So test.mosquito.org. After that, it's like, I not use this one. Let's put this here. After this, after me connect, I have to do what? On connect, I have to subscribe. So on connect, command, drag and drop. On connect, I have to do what? Subscribe. Subscribe where? Which topics? Very easy, right? Between codes, mol, P1, temp. I don't need to subscribe to distance because I don't need I don't care if the distance is less or more because there on this where I'm getting the information, it's done, it's okay because it's filtering every information that I send. Actually, it's not impossible to send information if I don't far enough. Okay, so it's not necessary to subscribe on the distance topic. If you see here, mol, P1, temp, that's it. So now I'm subscribed. I'm connect, I'm subscribed. Now the next step is if we entering a message on message, another block here, if entering, you see I'm clicking on MQTT protocol and drag and drop and the command decision. If, let me, Control C, Control V is faster here. If entering a message on MQTT protocol on this topic, mol P1 temp, do what? That means do what? So if you enter the information, let's say, first of all, I'm going to insert the value inside a variable. You have to insert this in a variable. So I'm going to use another block called read list. If I enter this information, I'm going to get this information and insert it on a new variable that I'm going to call temp pi, for example. It's not integer, it's a float variable because it's a floating point. So if I get this information, oops, double click, temp pi, that's it. If I get a message on this topic, get this information, get this message, insert on a temp pi variable, floating variable, okay? That's easy. After I get this information in a variable, I have to start to work on this variable. It's easy. So if you see here below, I have the IoT controls. And let's say that I'm gonna to put this information in a thermometer on my control panel. Just thermometers, just drag and drop the block, set temperature to not to 0, to temp variable. Double click here and you get this variable on the temperature thermometer. Good. Next, let's print it on, print it on the graph, on the chart, graph. Let's say that just if you see here on the chart, if you see here, you have different information on the chart control, and one of these is write data. Write data direct from the variable to the graph. If you see here, it's not necessary to set a range, to set everything, because on the control panel, there, where is it? Is here, is already configured. It's done. So if you come back to the coding, I just see here, here. If you see here, I have a write data information. This write data, the syntax of this one, you have to print the X variable, comma, and Y variable. So remember that the X variable must be from 1 to 10. So I don't have this variable. I have to create it before all. So let's create this variable here on setup. If you drag and drop the assignments block, if you see here, double click, and let's create a new variable called person. So it's an X variable called person, integer, okay? And person, let's start from 1, okay? So person equal a 1. So the first loop here, they read the temperature, insert it on the thermometer, and they write the data, double click, the person, comma, the temperature. So you're gonna do the following. Is if you come back to the graph, as soon as I get the information there, just print the temperature that I got from the Arduino YAN on this one. Now I have to do an incremental add to 2, to 3, to 4. So I'm going to do the following here. It's a very classical way to incremental. So before I write the information, I'm going to assignment to the following. Person is equal a person. It means that's equal a 1, the first pass. Okay. And after that, as soon as I print, I'm going to increment a 1. So double click, person now will be person plus 1. Person plus 1. So equal, it means the following. The first pass on this loop, the person will be equal to 1. So they're going to print on the graph like 1. And as soon as finish this block, it's incremental 1. So in the next step, the next pass on the loop, the person will the value of the person will be 2. So they print the temperature and the graph 2 and go this way. So that's it. Let's put this block below, because I'm gonna now turn on, turn off the LED, right? So now I have the graph done. Now, if this block means if the temperature is more or equal to 37.5, remember, or 99 Fahrenheit, do what? Let's turn on the LED on the control panel. If you remember, LED 1, it's the temperature is a green one. So it's a Boolean logical. So double click and tell it's the true. Turn on the LED. If not, Control C, Control V, double click, false. Right? And connect here. And that's all. But also, let's say that I'm gonna to include a peripheral, physical peripheral for Raspberry Pi board. So I click on Raspberry Pi board, right click. Instead, I insert IoT control, I'm gonna to add a peripheral. So a peripheral is a Grove peripheral, the same one. It's a red LED, add, close. If you come back to schematic, here is the Raspberry Pi, Raspberry Pi and the Arduino YAN, and here's a LED for my Raspberry Pi. connect to the D4, the 2, but I'm going to connect to D7. My real connection, I'm connected to D7. So save and come back to coding. And besides I turn on the control panel, I also gonna to turn on my LED, physical LED on the peripherals. Here's the peripheral, and here is the LED. So turn on is LED, and if not, turn off. Right? It's easy, right? And finish this loop. And also, if the person is more or equal 6, do also turn on the LED, but it's not a physical one. It's a LED number 2. It is one. Set state to true. And control. Oops. I almost finished, right? Sorry, my delay, but I think I hope you are enjoying our coding. True and false here. Okay. So now, finally, I just on my set segment display, I just choose set value of a person, not 0, just to counting how many people are entering on it. That's it. As soon as I finish, I just add a person on this variable and start the loop again. If I simulate this, I just save and simulate, you get an error. Just to show you the Proteus software indicate where is the error. It's of course if don't receive any message on the protocol, on the MQTT protocol, do nothing. That's it. Okay. So if you see here, it's done. My code is done. Let's try it and finalizing our webinar. Just simulate it. If I simulate, you get the same information from Arduino Yan here. And here on this environment, you get the control panel to test. If you see here, the below here is the LED, physical LED for Raspberry Pi. And in seconds, you get the information on the LCD display, and they are done to ready to go. Here we go. Distance 13. If you see here, I'm just changing the distance. 15, 16, 32. If I click press button, nothing happens. You see nothing in the graph. If you see here also on MQTT, I got nothing because I'm 13. Here I'm 16 because I'm 16. So if I come back here to 15, here, if you see here, distance 15, and I get, let's just say 32, 33, 34, 35 degrees, 35, 35, and I publish it. So from the broker, I get this information on that topic, and I get one point here, 30, 35, 35. If you see here is the same, and one person. If you see here, 35, 35, also you can get the information over there if you wish. So it's working properly. So let's go another person, another graph, another person, number 2. Let's increase the temperature to 30, more than 35, 37, sorry, 37, 65. So have to turn on the red light. Here you go. It's working. If you go one more, if you come back here, must turn off the LED less than 35. So this person has no fever. Next one. Go ahead. No. Oh, yeah. Now turn off. And the next one must turn the green light. Next one, green light. Here we go. And 37, 14, 15 here, 34, 14, 15 distance. Turn on the LED. So that's working perfectly. Lab Center, just to finish, Lab Center developed an app called Proteus IoT Controller. This app allows you to use it together to Proteus or to get to any Arduino Raspberry Pi board. You can download it from Google Play for Android device or Apple Store for iOS device. So it's free. You can download it and install in your tablet. So just to finish, let's deploy it to my tablet just to show you. I have another camera here. Yeah, I have another camera for my device there. I think you are looking my camera now. If I come back to Proteus, Proteus is simulating, keep it simulating. Now I have my tablet here. I have an iPad here. And if you come back, let's just check it out. If the tablet is connected on the same network of my computer, it's okay. And now I can open this app that I show you. This is the app that I showed you before. Just open it and click here and click here and discover. Must be, I'm not sure, it must be this one. Yeah, this one. If you see on the Proteus software, the Proteus just is not working anymore, the control panel in Proteus, but it is working now here on my tablet. And if you see here, I just published one information more. Let's say the temperature here more than 35. Let's put the temperature too high. It's very fever. It's danger, 40 degrees. If I publish it, if you see on the graph, go high here. If you see there, yeah, it's working. So if we click again, another temperature. Oops, publish again. Yeah, here we go. So now if you see, it's working properly, it's working very well. If I wish, I can deploy it to a Raspberry Pi. Let's do this, finish it. I already have done here. If you see, I have my my Arduino Yan working. Let me see if you can take a look on the display. The display is working because I already downloaded the coding there. It's difficult to see, right? Yeah, if you see there, you can see. It's my LCD display. I have moving the how to say the ultrasonic ranger 10 centimeters, and the temperature on my home is 20 degrees Celsius. It's for real. It's working on the Arduino board. If you see here, it's the Arduino board. And now let's deploy this code to the control panel for my Raspberry Pi. So just to show you how easy it is to coding a real board inside Proteus. Just stop the simulation is already stopped. Let's come back here to the project. If you see here, Raspberry Pi, my Arduino board, my Raspberry Pi board is connected to my network on my home, and I have here a port scanner. Port scanner is an application, it's free. You can download, and this scan all the devices connected in my network, in my computer also. Well, actually, my network. My computer is connected to this network, Netgear 5G. Is an internal network that I do here in my home just to do these projects. And if you see here, the Raspberry Pi is connected on this IP address. Final 6, okay? 192.168.1.6. My Raspberry Pi is connecting on this IP, and my Arduino board is connected to this one. So let's coding my Raspberry Pi. My Raspberry Pi is connected to this cable, to the network, to my modem. Let's coding the Raspberry Pi using the network. So if I come back to Proteus, select here Raspberry Pi, project settings. When I click project settings, I just type here the IP address, 192.168.1.6, right? Was 6 or 7? 7. Okay, that's it. And now, if you see here, I have a blue icon. When I click this blue icon, the Raspberry Pi must be coding direct from Proteus. If you see here below, oh no, I think it's 6, right? Oh, sorry, 6, not 7. I already forget if it's 6 or 7. Sorry, my mind is not good. Yeah. Yeah, here we go. Start coding. If you see here below, it's flashing a light here. This means that it's coding my Raspberry Pi. In the seconds, you get this information. Yeah, its firmware is complete. In this way, you can coding any project is directly from Proteus direct to Arduino. If I want to code in Arduino, just click Arduino, click in project settings, select the port, the Arduino. Actually, Arduino can be coding using Wi-Fi or using cable, dude. So you just select it and coding. I am done. The code, if you see, is working. Now Proteus is not working. I just close. Before I close the Proteus, just show you a nice feature. If I right click here, I just convert the source project to a C code. In this case, if you see here, just convert the blocks in C code in Arduino. For Arduino, if you see all the connections is there, the variables, you can see the C code and optimize it if necessary. And for Raspberry Pi, you can convert it to Python. Here you go. Here is a Python. So just to let you know that it's very easy, very easy to coding, and also to convert from blocks if you wish to Python and or C. So finally, I just closed this project. Just close the Proteus just to show you that I'm not using Proteus anymore. And let me show you here on the camera. Let me try to do this. I promise you, I just finishing. I just stopped my presentation, stopped sharing. I try to do this one. Let me see if it works. Yesterday I got it. Let me see. No. Yeah, maybe you can see very well now. Bigger, right? It's better. Let's close this. Is better. Yeah. So now
Yeah,
I
much
have
better.
here. What?
Much better.
Much better. Yeah. If you see here, I have now my Arduino board. Send the information. If I turn on keys, maybe you can see the. It's very difficult because the illumination can get information. But let's say here is working. I can see here on my display that my ultrasonic ranger is sending information correctly. If I go to above, oh, it's not working anymore. Not working anymore. Something is happening. No, man, what's happening? Well, I have to restart maybe because it's not working. I think it's not working. I don't know if it's the display. Let's do a test here. I have to see here. Just a second. Sorry, guys, about this. No, it's not working. Well, I have to restart here the Arduino board. I have just to restart it. While I restart, I don't know if you have any question, something more that you can have any question. Go ahead. Okay, no problem. Actually, we finished. Just I want to show you, if possible, the real application, but it will be the same. But just I'm gonna to connect on Arduino. Now I can show you. If you see here, I have the Raspberry Pi, and I have now the control panel. I'm not using Proteus anymore. And now the control panel comes from Raspberry Pi. If I show you, I think it's enough. Here we go. If you see there, I can do the following. If you see here, I can publish from this application. For example, remember mol slash P1 and distance. Dist. If I publish, for example, the distance is not working. Temp. Let's see. Temp. Let's see if it works. Temp 37. If I publish this information, yeah, here, if you see on the, it's working. If you see here on the tablet, it's not working with using Arduino, but now it's working. Yeah, it's working again. My Arduino board. If I forget this, if here I just click play here. If I click here, are you seeing my screen correct? Yeah. Are you see well my camera, Leo?
Yes, but we cannot see what is showing on the LED
Okay,
because
no
of the
problem.
light.
Okay, no problem. It's okay. If you see here, I have the push button, right? And here the ultrasonic ranger, and here I'm seeing the value that you cannot see, but you can see here on the tablet, right? So now I'm gonna to just publish. clicking here on the button, and you can, and if you see there is less than 15 centimeters, yes, just click, and on the tablet you must get something. Let me see, 2 centimeters. Yeah, it's working like crazy, but it's working because I publish a different way, right? I publish again. Yeah, if you see below, it's working. Just clicking here on the Arduino board, I'm gonna to click again, and I got the same temperature below. Yeah, here we go, 4 times. That's working, guys. It's working well. I just click here using Arduino Young board, and publishing information to the tablet through the Raspberry Pi. Okay, that's it. Sorry to delay too much. I try to do my best to go faster, but I have to share my screen again to finalize it. And I can, Leandro maybe can talk a little bit more, something more, but I don't know if you have time to talk about cloud license. I don't know if you have time, guys, to get information to know about cloud license, the new features. If not, it's just missing this one, the new feature for cloud license. Well, if you have time, I will show you. Here, Proteus software has actually 3 kinds of license. The first one is local license, and that you have to install on the lab on the university. It's not possible to use outside the university. And another ones is possible to use anywhere, network and cloud. The difference between them is that network needed a physical server. Okay, so you have to have your Windows computer inside the university to provide the license through the network. And the cloud license is not necessarily any physical server. All the information is managed in this dashboard that I'm going to show you for real here. The dashboard is here. It just, you open it and log in. Okay, this is a dashboard that you can see in real time how many licenses used by the users. Let's say the university can purchase 2 licenses or more, and each license can be 10 seats, for example, or more, 1,000 or more than 1,000 seats. That you can how do you say, administrate this license as you wish. For example, you can create divisions. Each divisions can be divided by city. Sorry, here is in Mexico City, in Guadalajara, in Mexico. So, for example, for Mexico City, you have deployed 10 license. For the Guadalajara, 10 license. And you can, for example, create groups. In Mexico City, you can create, for example, electronic lab or mechatronic lab or telecommunication lab, and create a reservation for these labs. For example, in the morning, you'll be deploying or do a group for 15 students using during the morning, then another one in the afternoon, and another one to the night. For example, you can validate and can set up all by yourself this information. The new version allows you to do also include, for example, where is it? Include IP address, is a little bit slow, IP address that allows you to do like a security. For example, if you want to be sure that that person or that student which receive username and password to use, he will be using or she will be using by just by himself or herself. And if you wish that they don't share this information with anyone, you can set up a IP address allowed. So you can use a VPN to connect it and do a list of IP address, and you can do a security on this or disallowed IP address. So you can create groups, like I said. So you can see, for example, the calendar for reservation. You can do the log file to see the errors, to see what's happened, to see the license, which license you used, to see the errors also. In real time, again, here on the license, you can see this is the new version. On the real time, you can see how many licenses used. You can set up everything. So it's very nice, very powerful tool to administrate and validate and create groups and visualize how many people are using real time the licensing on the cloud. So that's it. Very fast. You just should not lose any time anymore. I don't know if Leandro can tell something with you, Leo, or anyone has.
We have a testimony, right?
Oh, great. So I will provide you my share the screen. Okay, I'm gonna stop my share. You can share your.
Jason, you are here with us.
Yes,
Do you want to do live?
no, actually, I was actually wanted a couple of questions. I didn't want to interrupt him. He's doing an excellent job. And he had a daunting task to cover 1 million topics in a very short period of time. Congratulations.
Thank you. I'm like a running a marathon.
Yeah, I guessed as much. I actually took notes. That tells you, like, pen and pan, like notes, because of the circumstances, I was so impressed, and I thought I don't want to interrupt. You're on a roll, but I do have questions. You touched on a topic when you were talking very beginning about the migration that Lab Center would be looking at using FPGAs, which is very interesting. So the question would lead to is, what type of FPGAs would you be targeting? Would you be Altera, Xilinx? What would you be looking at?
That's a very nice question, Jason. I'm just I talked to Lab Center at the very beginning of this year about it, and I'm at Lab Center just tell me the following: Israel, talk to the customer and ask for the customer which FPGAs they are looking for. So Jason, they are just starting this development, and I know that some customer in Brazil and Mexico tell about some Altera FPGAs. So Jason, feel free to, if you work or have a suggestion, please tell us, and I bring it to Lab Center to insert your need to the second semester. Okay, they are working on it, and that's the question. They are just starting development, and anyone, if you can suggest and send us an email, or if you can put it on the chat there, we can for sure add these components on the simulation. Okay, on the next version.
That's awesome, because actually, to be honest, the reason why I ask is we have other courses that presently we're using Altera and Xilinx and so forth, based on the application and so forth. And this would be kind of like a nice bundling process, because by the way, I'm more on the IT side. So I'm deploying, yes, a few 100,000 years ago, I went through undergraduate engineering, electrical engineering, but we had no such thing as FPGA back at the time I went through. So it was this thing in the future, our programmable devices were gals and pals, so to put it bluntly. So it was very impressive when I saw that. I thought, oh, I see another course where this is going to come into. Second, so PCB, we opted out of the PCB because we more looked at, because we're in the COVID land and so forth, we didn't see us actually fabricating PVC boards. And I really see it advantageous to look at this in the future, to go there. And why? Because we have the LPKF two-sided boards where we can generate the boards.
Great.
Which means
I worked more than 25 years with LPKF. We know very well.
Yeah, well,
very impressive machine.
And that was one of the questions I had right off the bat was, if that's the type of system we have, you don't foresee any problem migrating into using the LPKF?
Absolutely not. If you have a time, 5 seconds here, I'm gonna to answer you in the best way, showing the integration. Just a second. Okay. Remember here, you see my screen, right? Remember the Gerber file that I generate today?
Yep.
Let's extract this zip file. Where is it? Where is it? Sorry, I cannot see it. Here we go. This one. This one I generate just today. If you see it, 25 March 2025. These are the Gerber file that you generate inside Proteus. Now I'm gonna open LPKF software. You know Circuit Pro, right? Circuit Pro is the machine software that's used to import Gerber files and also to manipulate the machine, control the machine actually. This is the software. I'm not connected. I don't have an LPKF machine here, so I'm gonna cancel just to show you how easy to work. It's recording, so you can follow these steps. So let's say this is a double side board, no plated. Just here you go. So you have to import this icon, import the information. Where is it? Let me remember demos. Here we go. This. So if you see here, all the Gerber files here, all you need for a double side board is top copper, control on the keyboard, bottom copper. You need also the mechanical maybe, and the drill information. Okay, so open. I'm opening I'm opening a just Gerber generate today. Okay, so it's nice. If you see here, I have a bottom side layer, and you have to select here bottom layer is already done. Here we have the drill, and the drill is already done, drill plated. It's very easy actually. Mechanical one, mechanical is the board. Mechanical not drill. It's a mechanical layer. So I cannot I can change over there. So in top, it's a top layer. So you go OK. If you go OK, you have the board already imported here. You empty you not use the layers. You can, for example, not visible, not selectable, not visible. The drill plated. No, the drill is this. No, the drill not. Sorry, and this one and this one. I just want to see the boards because the boards not have to be this color. Must be select this one. I think is not drilling. It's control routing. How do this convert to patch, copy to object layers? I don't remember how to. Sorry about that, but I think was easy is techno. It's here, right? Button click. Have to convert it to another layer.
It's fine.
Here, object to layer to board outline. That's perfect.
Wait, to be honest, the answer was you got it already. Yeah, it's support. It was very impressive that you had the LPKF software already installed. Congrats again. So the other one I was very impressed with was you touched on the one where you're talking about possibility integration with MATLAB. In the university sector, we tend to use MATLAB quite a lot. Is this in progress? Have you started this, or is it already being done?
No, it's already done. I did a project. I can send you a video, like I sent you for the STM32Cube. 32. I can send you a video to integrate. Actually, I have the project here. It's very easy, very simple. I have a video here somewhere. I have everything there. I have to check it out as it is. If it's not fast, I can send you later. I just have a video of this. Okay, to integrate. It's very easy integration. It's very nice. I can send you because I'm integrating using a serial port. I just using serial port. Here, MATLAB integration. I have a video somewhere. I send you in a second. Okay, if you have another question. Okay.
It was more of, I was more impressed that I was like, okay, this is good, because really, again, in the university sector, so we've got an asset. Proteus is an asset, and we've deployed it for our course. We actually kind of stumbled on Proteus. It wasn't one of those things that, hey, this one of the faculty members came in, we were using a certain microcontroller in our labs, and they wanted to kind of expand to different microcontrollers. And if you've ever been in the university sector, when you say, I'd like to use another microprocessor, it means the university now has to set up a new lab, buy new hardware. There's a cost. You can just, all you can hear is da-ding, 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 da-ding as it goes through. And so when the faculty member said, hey, I heard about this Proteus, can we assess it? And from the IT's perspective, my meat is, how do I deploy it in our environment so that the students can benefit from it at the same time as keep a secure environment so the students don't abuse it? So like this is kind of tug of war that goes on. Then, of course, COVID broke out, which was like a kick in the gut, so to speak. But hey, we already had Proteus in the pipe. And the idea that we could automatically deploy it and have students access it from home and automatically start doing their labs, it was like this kind of a light on event. So it was like bang on awesome. Yeah. Another question, you do the 3D visualization, which is another kind of a complete different section in deployment. Like, when we do from undergraduate students from electrical engineering, we focus typically a lot on the schematic, the ideal layout, we have other courses about programming. But then when we want to deploy, there's typically very little focus on fabrication. And fabrication is critical because on the circumstances, the naive idea is that anyone can just simply deploy. But then all of a sudden, as you put it, with this wonderful development cycle, usually naive students will go through the design, build the design, and then of course, when they discover they make a mistake, well, they throw that board out and they go back through the cycle again. And it's like 12, when you're learning, if you're a developed engineer and you know how to do the developments one stage, and even a well-defined engineer that knows his work gets a specification is always changed by client side. So the fabrication side becomes very expensive very quickly. So the idea of doing what Proteus does is, again, I can't reiterate, bang on. Too many times that we do the design of the board, we want to fit in a box, but you don't have the 3D perspective in place. So the 3D visualization was like, wow, okay, you've got that band covered too. Great. Question in regards to is, when you're looking at this type of board, is there a lot of requirements from the computer's perspective, from the user's perspective on the video card, or can we render this? Are you looking at the computer that you're using right now? Are we looking at a high-end GPU type video card to be able to render this, or are you capable of rendering this more generic based on computers?
That's a great question. My computer is huge. I think 8 gigas of dedicated video card. But if you see here, I have PCB tools, and if you come here on system display options, you can use it or not. You can use a Windows DID graphics. Let's use it. I just change it to it. You can use different kind of rendering way. So if you use this one, it's not necessarily a very powerful rendering. If you see here is low on the 2D environment, is slow. If you see it's so different, you can see the difference. And if you click in 3D, it's not too much.
No.
It's not too much. It's not high. It's not necessary. I mean, I use the 3D graph card more for the 2D than 3D. The 3D is like a regular. Is not to have another computer here working very well. If you see it's changing nothing, just close and open again, just to make sure that I'm rendering from scratch here, opening again. You see there?
Not bad at all. Because one of the reasons why I asked that question is, okay, because of COVID, students are deploying. One of the biggest problems we have is students at home. What are our expectations compute-wise that a student would have at home? And as long as we can render it really on the fly with not too much requirements on the student side, then this is a win-win-win-win.
Yes, absolutely correctly. I agree completely. If I see, I just move back to the 3D to the my card, video card. If you see here, it's very fast.
Yeah,
Very
it's
fast.
instantaneous.
But on 2D and 3D is the same. I cannot see the difference. As before, I cannot see. Actually, it's not necessarily a powerful video card, but you have to configure here on the PCB system display options. Okay.
Okay. Well, you've answered all my questions.
Oh, great.
That's good.
I was troubling here because Jason will be very great quest.
No. I was more taken away. You delivered the presentation beautifully, and again, I'm from the IT's perspective, so I don't typically utilize. I couldn't help but see as you're going through that. Yeah, I see immediate application for that. I see an immediate application for that. I can see entering this into another course. When we talked about the FPGAs, I can look at it looking for MATLAB. I automatically looking for the biomedical engineering courses where we're looking at acquiring data and transferring data for biomems testing. So it's like you kind of jump into things, and as I see more and more deployment, and it's really more of bringing faculty members on side to say, hey, are you aware this is an option?
Okay, perfect. Okay,
Great.
thank you very much.
We still have Jack Lee and Adrian. Jack and Adrian, do you guys have any questions for Israel right now?
Your mic your mic, Leo, is very bad. I don't know if Jason is listening the same of me, but
no, I'm fine. Thank you.
Okay,
Good
Jack.
project.
Okay, Jack. Thank you.
I don't have a question. Yeah.
Okay.
Yeah, I don't have a question. Thank you.
Thank you.
Thank you. Jason, I put on the Zoom chat a link for the MATLAB video. Sorry, it's not 100% done, but I think it's in Portuguese also. I'm not sure. just to introduction about the theme. Okay, just to.
No problem. One last question regards to when you do your licensing, is it possible when you do your reporting, I notice you do real time, but if it's possible to do with respect to time. So for example, when I deal with my boss and he goes, oh, how we've got 200 licensors, how do we, how are we using them over time? It would be nice to see kind of a logged data log.
Yes, just a data log of usage, not on real time, just to get, yes, it's possible. Yeah, I just close it, but here is possible to generate log of licensing. For example, if you just download this log, you can get all the information.
Okay, they're loading it into MATLAB to do the plotting. Okay.
Yes, exactly. Yes. Okay.
Thank you.
All right. So, Israel, what is the?
Sorry?
Okay. I believe we covered everything and a little bit more with the help of Jason. I don't think that we even need to show his testimony because he's already he spoke a lot and everyone could see that he's very into Proteus, and I believe Proteus is working well with Rhinestone University, and Jack and Adrian, the other guys, they already left, but we do have an evaluation license. If you don't have an evaluation license, we can provide you for at least 30 days so you guys can working and make the test that you guys need. We can give you support during this time. So if you wish, after this meeting, the webinar, we're gonna send you an email and get some information so we can provide you the evaluation license. Okay. So if you don't have any other questions, the only thing that I can say is thank you very much for your time. It was a little longer than we thought, but I believe we covered everything. So if you have any other questions, I put my email on the messenger, on the chat. So please feel free to send us any questions that you guys want to be answered. All right, Israel was awesome. Thank you very much. Appreciate it. And I don't know if you have any other. I know that we have other webinars coming up, so we're gonna spread out these informations later on with you guys.
Yes, absolutely. Yes, we're going to do a webinar focus on PCB design. Maybe it'll be very nice for Jason and everyone. So let you keep in touch, and you can do you see in the next seminar. Thank you very much. Keep safe.
All right, guys. Thank you very much. Have a good afternoon. Bye bye.
Bye bye.
Thank you.
Thank you, Jack. Thank you, Adrian. Ruth. Thank you. Bye bye.
Bye.